When we talk about things like object-oriented programming, there's a whole bunch of design issues that I want to talk about that the language developers have to decide when they talk about when they decide about their language. The first thing we need to talk about is the exclusivity of objects. What does that mean? Does the language use objects exclusively? For example, Smalltalk, everything is an object. Everything, I think in Scala also, everything is an object. Even numbers are objects, number 5 is an object. Everything's an object. There's no mixture of anything else. Everything is an object. What is the advantage of that? So the advantage is that there's a consistent look and feel to the language, meaning everything behaves the same way. I think we have a word for that. It's called orthogonality. Right? It's easy to learn, easy to manipulate, and deal with. The downside is that even simple things like that, no way you can just use simple commands, machine commands, becomes cumbersome. Instead of just adding two numbers, it becomes a function calling thing. Instead of things that are just easily translated to machine language commands, becomes a big issue. Usually that's obviously very slower. So the first issue is exclusivity of objects. So we said about one option that we have is just that objects are used exclusively. Another option that we can actually have is taking a language that has other types of data and adding objects to it. That's what C++, for example, did. C++ is not a pure object-oriented language. It's actually an imperative language together with object-oriented. So we're adding all kinds of object-oriented infrastructure to non-object-oriented languages. The advantage of that is that we can actually decide for efficiency reasons when to use one and when to use the other. The disadvantage is it becomes a big language and things behave differently. And you can have two programmers in the same language who actually can't read each other's code because this one went and he learned that part of the language and I learned that one part of the language, and we have two different paradigms running at the same time. A third option, which is somewhere in the middle, is the one that was chosen by Java and C#, for example, is to be an object-oriented language, except for some basic types, right? What's called known as the natives, right? All the natives, right? All the basic stuff like integer and floats and all those, right? They are not objects. So if you look at, for example, at Java's object tree, you see that you have two branches. You have all the objects and these things, right? So the idea is that everything should be an object except the things which are basic and should not be implemented as objects, and they are actually not implemented as objects. So the advantages to that is that you can get the efficiency for simple commands that you can get from non-object-oriented languages, but you get the look and feel that we see in object-oriented languages for everything else. The disadvantage, obviously, is that if you sometimes mix and match between the non-object branch of the tree and the object branch of the tree, we get into trouble. Meaning, for example, that if you send a number to some place where you're expected to get an OBJ, an object, right? So we have to figure out some kind of system how to get that to work. So that, for example, in the Java and C# and others, there's box in and box out. There's an integer and there's an integer. There's you have a little int and capital INT. What's the difference between them? An integer is just the primitive. It's a native primitive integer that we all know. And the capital INT is an object that holds an integer. Why do we need these two things? So the reason is exactly what I mentioned. If we send an int to a place where we're expecting to get an object, that wouldn't work. Unless we have an int object which has a constructor that gets an int primitive, right? And then we box it in. So we have a box in, box out, and other wrapper, all kind of wrapper objects. And the reason we have those is in order to figure out how to get the primitives to work with the objects, because we actually have two different branches of the tree. So as I said, when we deal with object-oriented, we have the exclusively object-oriented, they just take object and stick it into the language. And the third option is somewhere in the middle, which is, well, object-oriented except for. So that's the first design issue that I wanted to talk about. The second design issue I wanted to talk about is, does a subclass behave as a subtype? And what does that mean? There are languages that allow you to create a subtype, in a sense that I can take, let's say, all the characters and create a subtype called caps, capital characters, right? So capital characters is a character, just it's a subset of the character. Now, obviously, every place where you can place a character, you can place the subset, because every capital A is also a character, right? So that is a subset. Now, the question we do with object-oriented is a subclass or a derived class, is that a base class as well? Now, you might say, well, sure. Well, there's actually different ways of looking at it. You could just say, since it's an implementation hack, so no. You can say yes. So usually the standard way of looking at things is that a derived is a base, and therefore every place where you can put derived, base you can put derived. Now that's not always true, by the way. For example, in C++, we have public inheritance and private inheritance. Now, private inheritance is is a relationship. Private inheritance is just an implementation way of doing things. You can actually go and just write the base as a data member of the derived, and it will be almost the same thing. But when you have a private inheritance in C++, for example, then it is a relationship, and you cannot put the derived wherever you can put a base. But in public inheritance, it is true. So we have these design issues. Do we want to allow the derived to be a subset of the base or not? Another design issue is, does the compiler check during polymorphism whether the type of the functions, the prototype is equal? And what does that mean? Suppose, for example, that I have a base class with a function foo that gets an int, char, and a float. And I have a derived class, which is derived from base, obviously, that has a foo that gets something of type S. Now, when you go and you create a polymorphism, what you're actually doing is you're creating a base pointer that points to the derived. And what you want is that during runtime, and notice the word runtime, it should decide what the real data that we're pointing at is, and based on that, decide what the function is. So the code we see here on the board, in a sense, is a class base, just like I described, that has a virtual foo that gets an int, char, and a float, and does whatever it does. And we have a class derived that gets a something of type S and does whatever it does. I don't really care. And we have on the right side the polymorphism that we're expecting to see. This is the polymorphism, right? This is the polymorphism. And we have a base PTR pointing to a new derived, and we have we call it a function foo, we send it an S. Now what this actually means, during runtime, it should see that the function it should be calling is this one. Why? Because since bptr is actually pointing at something which is derived, therefore the function it should be calling is that function. And therefore this actual function calling should be legal. The problem is that during compile time, the compiler does not know what is the pointer really pointing at. As far as the compiler knows, bptr is of type of b star. And therefore, how can it know that this function is legal? If you look at the original function in the B class, then it's supposed to get an int, char, and float, and not at something of type S. And therefore, how is the compiler supposed to know that this is actually a real legal call? Now, if we had another function here that said void foo, that gets an int, char, and a float, and does whatever it does, then this actually would work nicely. But the way it's done right now with the S, the compiler, when it looks at this line, has no way of knowing whether this line is legal or not. And therefore, the compiler is standing in front of it actually a problem. It is not sure whether to allow this to commence or not. And the problem here, again, is the type checking. It's a type checking problem. Do we break the type system, or we say no? There is no function in base of type foo when it gets an S, and therefore this is actually illegal. Now, the way this is resolved in most object-oriented inheritance and polymorphism is that the compiler checks, in order for polymorphism to exist, then the prototype must be the same. If we take a look at these two lines, this one and this one, then the prototype is the same. And since the prototype is the same, therefore this is polymorphism. But if we crossed out the second line down here, if we crossed it out, and we just left it the way it was, then the compiler is not going to allow this. It's not going to say, oh, this is legal because it might be legal. It checks for the types of the prototypes and the types of the parameters of the function during compile time. And during compile time, then BPTR is of type of B star, and since it's of type of B star, therefore this becomes not legal, and we do not allow it to break the type system. The next issue I want to talk about is the issue of multiple or single inheritance. And what does that mean? Does the language allow a derived class to inherit from multiple bases? Now, how would that look? So you might have a class that looks like we have a class base that does whatever it does. I don't really care. And then we have a class derived base 2, let's call it, that does whatever it does. And then a class derived that inherits from public B and public B1 or B2 and does whatever it does. Is that acceptable or is that not acceptable? So that's a question that's actually being debated. It's still C++ allows it, Java and C# do not allow it. And the question is why? So the reason behind that is because we might actually reach what's known as a diamond hierarchy or a diamond inheritance. Meaning to say, suppose we have a class base and we have a derived 1 and we have a derived 2, they both go and derive from base. And then we have some double derived that gets both of these derived 1 and 2, and we get a diamond hierarchy. What is the problem with a diamond hierarchy? Well, suppose, for example, that our base includes a first name, a data member called first name. Okay, so this first name would actually be in D1, and it would also be in D2, because they actually inherited from base. Now, if we look at double derived, well, something funny happens. We have both F name from the left one and F name from the right one, and we actually got schizophrenia. We have a double, and we're getting both data members from both sides, and we're actually getting it double. Now, you might say, who cares? But this becomes a maintenance nightmare, that when you want to actually say, I want this one, I want that one, you have to quantify everything. And the worst part about it is you might not even know this is happening. So you might have an entire hierarchy behind the scenes of the relations. Everybody's inheriting one from the next, and you might get some kind of diamond inheritance, which is actually a problem. Now, how does C++ deal with this matter? Well, they created what's called a virtual inheritance. That means that we write here the word virtual, and possibly here also if we want, the word virtual. And what that means is that only during the runtime do we decide, or during actually when you want to create the object, we decide how to build the actual data members of the object itself. And therefore, if we have this kind of case, it's not going to create two F names, it's going to create a, if we have to depict it in pictures. So normally we have an object of type base, and then in derived, it would be made up of type base plus whatever derived added to it, derived to. The same thing is true on this side. It will be a type base inside and whatever derived one added to it. And normally, The double derived, the way that would work is that you would have a data, and inside you would have the left side, which is the base, plus the double 2, and the base plus the double 1. And that's the reason we have our little schizophrenia. What virtual inheritance does is it says, no, do not create both bases, only create one once. So that would allow us to actually do the following, and it would look like that. Now that's a very complicated thing to implement, and it's also very not intuitive because the people who actually inherited from class base 1 or base 2 might not have known that they're actually inside a diamond hierarchy. So languages today, like Java and C# do not allow multiple inheritance. What do they allow instead? So instead, you say, oh, we do allow interfaces. What are interfaces? Interfaces, in a sense, are inheritance, but not in the same sense. For example, a Java class or a C# class can inherit from a single base class, but from multiple interfaces. So what is the difference between that and what C++ has? And the answer is that an interface is the inheritance of behavior, not of attributes. In a sense that I say, okay, we have this function, we have that function, we are inheriting the behavior from different places, but attributes themselves you can only inherit from one location. This allows for this diamond hierarchy problem. You do not create schizophrenia in the sense that I get the same data number, the same attribute from two locations, even though it's the exact same one in the base. I can only inherit from attributes from one location, but behavior you can take from any as you want. So if you think for a second what attributes are in a sense classes without data. It's classes just of behavior. That is an interface. So you are allowed to inherit multiple behaviors because the diamond hierarchy can't do that any harm. But you cannot inherit multiple attributes from multiple locations because that can cause us harm. So we see again design decisions that languages go through because of all kinds of decisions and problems and ideas and solutions that we actually see in all different types of languages.